Hello everyone, myself I am Thoi Singh, lecturer in mathematics. I will be teaching you 11 and 12 maths. Hoji koi chapter 2 gi makha tarak poina rules of differentiation sijo 11 class ki ne 11 dan oina thengnar ba ngak tani ko sida rules khara amtang remind tause. Number 1, d by dx of constant am lere fx lere constant to mopan thang dok pa ya heba magi rule sama koi tame. Then rule number 2, d by dx harga function mayam addition or subtraction fx plus minus gx plus minus function mayam naranjanu addition orambe subtraction orambe duitari d by dx harga operator je tongan tongan sang yare magi rules ta ka there is akona fx gx ebe mota ub the notation logai tari u have a function b have a function mayam plus minus our whole dash means akoi derivative logai tari tongan tongan distribute sang kanda u dash plus minus b dash plus minus areba function mayam adum differentiate tor sat ki be I have any plus like minus like. Then third, d by dx of fx gx function any multiply tor lere duitari magi expansion di kamai toi fx d by dx of gx plus gx d by dx of fx akoina first function second function ha ga jui function ani first second like kanda first function thang do ani second differentiate to ani plus ha ga second ong thang do ga first ong differentiate to have that is ub notation the ub dash whole dash equal to ub dash plus b u dash and function ahum le ramaga di ani thang do ga momum sum differentiate to changi do ne ya ko sigi expansion jibo koina magi rule sibo koin kai kograba Leibniz or product rule ha khangnagre yak. Next, for the d by dx of fx by gx cosine function am le ditari combine la asigna denominator gi square gx square matak tamo denominator lengna tame d by dx of fx function numerator gi domo differentiate tore minus function mathak ki amuk fx to tame d by dx of makha dong differentiate on gx yako ub notation di u by b all dash my derivative lo kanda makha the denominator the b square mathak the makha the length tham dene b u dash minus u b dash yako sina koina kai haigraba cosine rule. Then anokba ma mo kai the rule some hapsalaji without proof in number 5 the dy by dx in lere sida duitari aina variable ama hapsan jeba koina dy by dz by dx ngakang koina wakal the cancel out to boy aina khanje dz ka dz to manabni na numerator ka denominator ani do cancel to gra di left side ke dy by dx ka do manai den se koi chain rule ko dy by dx per mane z se koina hapsalu bane yako admai to dina koina apam variable masing pa ta pe ani hapsan ge ohum hapsan ge se amu ani hapaga di koi dy by dz by du by dx and so on koi variable je koina apning mon hak ki ye sigi pattern ji da koi dy by dx dum puthok pa ne. So this is chain rule yako. Then again 11 the koina mung standard derivative ma ma koi first principle the definition the koi limit ko ten derive to giba standard derivatives ma am do mu remind to minus sidale constant ki derivative 0 x to the power n x to the power n minus 1 sin ki derivative cos ki derivative minus sin tan ki sec square cot ki minus cosec square sec ki sec x tan x cosec ki minus cosec x cot x si ma jano 11 the loi derivation haigra ngak tani aduga standard formula ina koina loi phag ngak tani yar ko makha tar pa koi atopa mayam ma amuk loda se formula atopa mayam. Then derivative of explicit or composite function. Explicit function the gain function of the form y equal to fx have the y is explicitly defined in terms of x only have the y have variable the right side the lakan the function lakto me and the variable do x ngak the sinner go define to ngama ba do tari to mo type function do kaina explicit function are khangne do function no function am gi manung da jawar ma ga do kaina composite function do adu hire ga so dum khangbe ai ko say example am lower yang se let y equal to sine of x square plus 1 do it say explicit function where kari ge y hairaga right side le je variable je x kaktani or composite function oina hai ke gina kan sine trigonometric function ni aduga angle the line and x square plus 1 je algebraic function ni trigonometric function ga algebraic function ga combine tore aduna si composite function ko hai ko then dy by dx mai buthoi khoi yang shape hai ko so da koi amuk equation ama amuk variable ama introduction to ji let x square plus 1 equal to z let this be equation 2 then masai given equation 1 the option tadi x square plus 1 ki jaga z hap tadi kai phange y equal to sin z lere then hoji ta koina channel to bu dy by dx a variable ano z ama option tadi dy by dz by dx lere channel y value option z do tadi d by dz haga y de kai sin z d by dx haga mu z ki value de kai x square plus 1 sida lore is kai d by dz hai tadi we are differentiating the function with respect to makada dz to na with respect to z having a function to z ngakta oidiaro d by dx haga na differentiate to the function to x ngakta oina bane sida z hapaga koina semai itari nungsai standard derivative no sin ki derivative kai ne hagra koi cos ne na koi phare habani ado si sin z with respect to z variable sa mana me na sin ki derivative kai tare cos z then d by dx of x square plus 1 je songare plus like on the x square ki derivative kai tare twice x constant ki kai tare 0 either ju are so twice x thangdo cos of haga z to nga sai koi putting low ki by x square plus 1 da mu hale do tare sina dy by dx ki value do phange so chain rule je koi palu ka da function do si pick pai dum am sang da one function do composite function do complex or maga di chain rule je am tedious or ba lengthy or ba koi calculation ni aduna shortcut da koi mu kamai to ya ge je mu yeng je som da mu yeng ko again sai equation 1 ji da dum yeng je y ki value je kind of sin of x square plus 1 so that dy by dx direct differentiate to sale dy by dx sub sale right side dy by dx sub sale sin of x square plus 1 koi khan bagi process kitang hung do kan da hoji derivative d by dx a derivative of harga makha da dx with respect to x koi x reflect to deni x ne na khan deni ada koi kai pare ham da dy by dx a kai pare ham da sin pare do that standard function 11 ge hoji to koi na yang mina give the sin paramina formula da kai yawi sin x ki formula yaw no tari sin of x square plus 1 hai je angle x square plus 1 pun koi na x ne assume to je sin x ne na ngak assume to je no tari sin x ki derivative te kai tare cos x ado x oram de koi na assume to give ni amon na x oram da gi into d by dx har ga koi na x ne assume to give jaga do amon differentiate to sala je so d by dx of x square plus 1 hapsa like ko the differentiate to x square plus 1 do twice x khatang phang mapan thang dore du tari dy by dx value kai tare twice x cos of x square plus 1 phang ngasai chain rule palaga somna kan do hot paduga somna kan diga answer dy by dx value samanai din yar ko ana koina exercise the problem solve to kan da koi chain rule je koina wakan da dum thamaga somna kan shortcut je koi apply to no langna doini koi matam save to na yar ko then coming to derivative of implicit function implicit function is in comment to am tang yem na chika an equation of the form f of xy equal to 0 in which y cannot be expressed in terms of x is called an implicit function of x and y have the koi sai y equal to have right side x ang tele mo handa mukti y je explicitly in terms of x define to ma to x ko y ga variable masing yam khalak pai tar yam samba yam lai ba wakhan x implicit or ga di x y variable mam yaw le mane y zo am khaktang le ma roi siguma function le ram kan da magi dy by dx pu to ko di command to to find dy by dx we differentiate both sides with respect to x equation with respect to x differentiate direct differentiate or phang do ne again example am lowering find dy by dx if y plus sin y equal to cos x the y ani le right side of cos x have a function ang la so dy by dx puto is implicit function ko ne So okay, direct differentiate or my solution the differentiating both sides with respect to x. Okay, differentiate that means d by dx both sides half half. Then d by dx okay plus like and distribute the dy by dx plus d by dx of sin y equal to right side ki d cos x derivative log doni with respect to x variable samana banina cos ki derivative kai tagre minus sin. Next tamu dy by dx plus sida mathak is the d by dx of sin y is the variable man there. We are differentiating with respect to x, but the function is sin y, that is defined in terms of y. So sin y is koina among the taugiba the sin x ni namitu warni sin x ki derivative ti cos x hamina cos y ire, but x or the bigi y the omona differentiate torni dy by dx tam equal to minus sin x. dy by dx come along 1 plus cos y dy by dx equal to minus sin x. Therefore dy by dx 1 plus cos y transfer line sitar. So this is your dy by dx of the implicit function y plus sin y equal to cos x. Then derivative of inverse trigonometric function. Inverse trigonometric function je koi 11th tamak chapter 2 class 12 ta koi tamre ko magi derivative te kamai to yemu yangs koi hana formula do amtang yeng to se koi na sum yeng mate sinu ngai na ko. Number 1 d by dx of sin inverse x equal to kai manani 1 by root over 1 minus x ko koi hoji loi prove to we anes. The mind on second cos inverse ki derivative na minus 1 by root over 1 minus x ko ani ji kana bje samane cos inverse na minus yaw khakta ne sin inverse ka value samane cos inverse ki na minus yaw. Likewise tan inverse ka cot inverse ka di samanani cot inverse ta minus. Then sec inverse ka cosec inverse ka jo samanani cosec inverse ta minus yaw minus yaw pattern je d by dx left side the differentiatory function do c na function do maming do c na hormaga di minus yaw do ni noi ningjang manungai na ban has minus yaw do je ke do ba nang differentiatory function c na hobagai minus lo yaw ne kya ko ri 1 gi proof che kamai lai no amtang yeng che ko. Let y equal to sin inverse x, then inverse ki definition matung na khoi kai phange sin inverse from the transfer line kalon do tari sin y equal to x. We differentiate both sides with respect to x, we get side chain panji with respect to x ni ko sin y je sin x ure do tari cos x adu x nate y oram by amon differentiate tore chain rule ne apply tore je dy by dx equal to right side t dx by dx t 1 time. So dy by dx ko te cos transfer akan 1 by cos piram badi sin function in a cos is sin all utari root over 1 minus sin square y. So what is sin y? Sin y is x absolute utari dy by dx of sin inverse x y d sin inverse x ka mana given equal to 1 by root over 1 minus x square tari proof tore in 1. Same patterns that no second gi third gi lemo reform la me the same patterns that prove to one no try to ko. Coming to derivative of exponential and logarithmic function. Exponential function je koi edum 11 the ka thang have the variable the power when la ko do koi exponential function koi logarithmic je amtang yeng je kamai la no se ko logarithm. Let b greater than 1 be a real number such that b to power x equal to a. B is a real number any real number 1 that is out there the positive number was b the power x haga a have a number then we said that logarithm of a to the base b is x high. So symbolically symbolically if b to power x equal to a, this implies log of a to the base b equal to x erf. Karigumba b to power x a ga manaragadi. Ai ko koi na ngasai log riba b je 1 dei chawni na x a any value low nang positive log ra negative log ra x ki value je kai tar ni a ki value je b to power x have ni b to power any low kanda it is always positive. And a high value it should be always positive. That is log high kanda koi pa kanda log of a to the base b hai kan lo kan da sai a is it should be always positive negative or ga koi define to de ko ya ba so numerical example amani dang discuss to kan ma ek 2 cube se 8 ka mane si de loi khangi du tari log ki notation sin kan koi kama ya ba log of 8 to the base 2 is 3 similarly 10 to the power 4 is koi 10,000 du tari log of 10,000 to the base 10 is 4 sini log ki definition lays yar ko definition khangani then noi na sida section the note kitang yengsi in log of x to the base b log of x to the base b if ngasai base b is 10 ga manar ba base 10 or ma ba dui tari log se koina kai ha ka khangne ha kan common logarithm ma khangne adum noi han dum yam tarang mani ko to subject is common logarithm guys if the base b is e is again okay 11 the Euler's series ta thangna ba Euler's constant irrational number to ni koina irrational har ga pi gi da 22/7 by 3.1415 kind like the mine e is 2.71 approximately man the constant this is a constant fixed constant which is irrational like approximately 2.71 ga man hai base b do koi e ga manar ga de log to kai karne koi natural logarithm karne yeah then natural logarithm case the mayam gi e by convention je kai are hojik asai log of x to the base b do e log tari kai phangani log of x to the base e hai and that natural logarithm ki case de koi e do inner row ba e do ji hai log x tang ye are logarithm symbol je e kan always there should be a base but in case of natural logarithm base e mean koi e do ji hai so log x e kan the base kana le no e le khang doin or topa notation the koi small ln x is koi log x hai ne ko which is natural logarithm yani ko logarithm definition je then magi logarithmic properties khara koi daina da ba te ko properties me koi phana max khang je ko property number 1 da kai le log of x to the power n equal to n log x property 1 da le je koi base yaw bra yaw de so this is natural logarithm but the property 1 nang na base any base ha pa ko tum yai I log base a absolute some can right side is base a half tare do tare some can left nang base of 5 oi tare right side of 5 half tare that's the p is the natural logarithm the p ni ko number 2 see jo natural logarithm da dum harage log of x y I the number ni multiply tare log lai ra do tare log se koi tongan chang kan kai win sang be log x plus log y plus win sang be number 3 divide layer magadi log of x by y is kai chang be log x minus log y minus 1 chang kan makha video minus har say 1 2 3 khoi hoji base e oi banga tani karigumba khoina base e oiram dagadi khoina magi differentiation to yanam langna kan base e the conversion ama sange duna base conversion ge property na kamai to hai kan number 4 log of x to the base y layer me base e oi the base y oi ka the base e on thokai tari kai wani log of x divided by log y see base e the loi convert to gram china base conversion gi property ni ya ba chema chena kangjalo base conversion je then number 5 any x possible number om lai khalo di tari any number positive number om kan ma je log ki notation sinner e gai tari khoi kai bi yai hai kan da e to power log x e bi yai yeah ko sima jam important oiba property ne ko so these are your logarithmic properties seda mo koi note oina magi particular values khar khang na ba kitang note ama note tokshan ji ko log of a to the base a is 1 tar see ngasai nang base conversion property number 4 to apply tokshan tar base e oi da mina log a by log a samana ba ni divide tore a is positive number ni ko 0 na te aduna samana ba non zero number ni divide tore ba 1 tam ni na it becomes 1 have the log are nang na log do number to ga base to samana ga de my value is 1 tan have sida koi deduct to kan log e ju kai ta ni 1 base e log do number to log of e to the base e samana 1 ya ko then log of 1 to the base a is 0 ngasai log ki definition da amtang yang ga yang koi ngasai 2 cube equal to 8 like kan da log of 8 to the base 2 is 3 I give it ꯑꯗꯨꯒꯤ ꯗꯦꯐꯤꯅꯤꯁꯟꯗ ꯌꯦꯡꯀꯥꯟꯗ ꯑꯗꯨꯝ ꯇꯣꯂꯣꯡ ꯇꯥꯕ ꯈꯜꯂꯨꯀꯣ. Then some results on derivative of exponential and logarithm. Magi result without proof amtang magi formula homdang koi discuss tawse. Number 1 the derivative of e to power x है e to power x कमाना. Derivative of a to power x ना a to power x log a. Then derivative of log x ना कहता है 1 by x. So this is your standard formula of derivative of logarithm and exponential function. Derivative of parametric function. Parametric function जने कमाई तो बना मु यंग मिने चिका. Parametric form है बा मा हाने यंग ची parametric form जे कहीं नो function ये. A relation between two variables x and y expressed in the form x as a function of t and y as a function of another function t is said to be in parametric form with t as the parameter. Have the x को y का relationship हम ले दोने अब अदो मबानी की मरकता direct equation हम दी even दो but x in terms of another variable t that defined tore y is in terms of another variable same variable t that defined tore do ani du x ko y mark the relationship lai reno kana na connect toriba t y variable duna that is such type of equation ja koi kai koi parametric form kore connecting variable duna koi na kai ko ba parameter ko ne ai ko du ja magi dy by dx ko to ko je kamai lai che koi channel dagi imtang yang ji dy by dt da koi x option kan da channel apply to santari dy by dx dx by dt lai right side ke dy by dx thamorga dx by dt transfer lagta ri divide chakre dana so dy by dx equal to dy by dt divided by dx by dt provided denominator cannot be 0 sigi division je apply to koi dy by dx ko to kane so example am lower koi gyan tan so find dy by dx if x equal to a cos theta and y equal to a sin theta. So the period x ko y equation ani period x in terms of Canada defined tore variable theta y is same variable theta do tari such type of equation je parametric form kore connecting variable je theta se ore se kai kore parameter kone aside definition in terms of t jani ko admai to dana connecting variable do t or they have like theta or be u or be v or be koina dum how the low ya ne yeah then solution amtang butok se x equal to a cos theta ne my derivative low tari a constant length ne thame cos ki di minus sin theta le re again from the y equal to a sin theta ne magi derivative low tari dy by d theta low kai gena with respect to theta defined to na a constant length ne thame sin ki di cos theta ne then mathak ki definition da dy by dx ko ke de ke do ba dy by d theta divided by dx by d theta apply to ne channel do ya ko value phang di ba hapsale we simplify it we get minus cos theta so minus cos theta is the derivative of y with respect to x so the results am tang yang ko na putoi dy by dx ni odo result na ko in terms of theta the type say parametric form oi be ni form oi be ni ko mamang da ko na dy by dx puto kan da di explicit function da in terms of x ngak ta do ni implicit function da na xy ma mix tor ga ta do ne ha the results in the xy da loi la app adu parametric form da di result say answer do in terms of theta la pe or simply a constant function da la ko depends on the rule of the function ko low function da depend tor ko second order derivative se amu kai haino se ko amu yang sika ekta definition dum ko example oi kari oi let y equal to fx be any given function then dy by dx ko mamang the notation ko hemin nagre f ds x command let this be equation 1 if the right hand side f ds x is differentiable I want to differentiate the we then differentiating 1 with respect to x we get the d by dx both sides absolutely equation 1 absolutely d by dx dy by dx equal to d by dx of f ds x if this exists my value le ramabo then it is called the second order derivative of y with respect to x and denoted by d2y by dx square. Read as d square d2y by dx 2 pane. It is also denoted by अतोप सिंबल द कई लेरे f double dash x or f double prime पागेरा f double prime x or y double prime or y suffix 2 or capital D 2 y सिंबल मैम लेरे अदा मैम कमन ओरे जब कोई d2y by dx square कमन अदम ओरे f double prime जो अदम कमन ओरे को so example हम लोग का साइ second order जे कई है नो जे हम तंग जानता नहीं कम तक नते second order अनिरक differentiate तो आमने अमुक्तंग differentiate तो होगा first order derivative अनिरक तो होगा second order derivative likewise third order derivative fourth order derivative it goes on मैम लाइबे है दोनों एक syllabus से द second order derivative पक्तने अपने याद दो जिका so example हम सिले find d2y by dx square if y equal to x cube plus sin x say y है by explicit function हम पीरे in terms of x defined over x cube plus sin x ना दो तारे मागे second order derivative पुतो होसिनी solution we have the given function is y equal to x cube plus sin x therefore differentiate over dy by dx equal to see differentiate तो तारे कई तारे x cube की दी thrice x square sin इन कई तारे cos x तारे again second order पुतो कई तारे d2y by dx square है किमने d2y by dx square की कई माना करे dy by dx of dy by dx की माने so dy by dx of dy by dx तो कोई मतलब तक लोअर का thrice x square plus cos x ले रहे सी डिस्ट्रीब्यूटर अमु हना डिफरेंशिएट तो तारी thrice x square की डेरिवेटिव ती 6x cos की ना minus sin so सीधा फंगाई बा 6x minus sin x है ऐसा given function y जो कि second order derivative ने then coming to next topic mean value theorem mean value theorem जिदा कोई theorem अनी लाइनी से without proof ने only statement खक्ता नहीं कोई ना discuss हो दो जे द हम बता कोई Rolle's theorem है बमा कोई नहीं ना सिक्का mean value theorem जिदा Rolle's theorem है जिकाई if a function fx defined on b such that higher condition में हम satisfied हो दो नहीं Roman number 1 the function f is continuous on the closed interval ab Roman number 2 the function f is derivable on the open interval ab and third condition the functional value at a must be equal to the functional value at b see whom they satisfied to then Rolle's na hai mujhe then there exists at least a point c belongs to the open interval ab such that f there c equal to 0 hai ko si statement je noi pha batai sida hai je Rolle's theorem na hai je kaigun function ma closed interval ab hai bam the continuous or open interval ne na derivable ore adu function the extreme point a da b da my function value low kan da ani je manaraba ai tari function the differentiate to kan da open interval a ga b ga mark to level at least a point means point amadi phangde ya de ani phangje ahum phangje hai point amadi phangde ya de such that asai mage derivative to 0 oi ba jaga right ada si ge last ke the f dia c hai je koi derivative se mage application of derivative la kan da no na makha ta ba chapter je do dum sida in detail se yaro keni 11 दस याव करबनी f दिया से है जे के मागे ज्योमेट्रिकल जे लाइन अमगे स्लोप का माने है लाइन के स्लोप का माने तारी स्लोप तो 0 ता है हमने स्लोप 0 तारी कोइना लोअर क्लास दी 11 द कई फंगे लाइन अमगे स्लोप 0 दी लाइन दो x एक्सिस द पैरेलल ओइना कोई फंगे याय को तो तारी Rolle's theorem जना कई हाई नो जे ज्योमेट्रिकली येंगनो बलाना कांदा कोई ग्राफ हम तंग यंगसे होसे सिगे ग्राफ से दखै कदरे Rolle's theorem satisfy तोरगे येक प ग्राफ ने Rolle's theorem द काय गे डिफाइन तोर क्लोज इंटरवल a दगी b द फंक्शन द कंटीन्यूअस ओइबा मींस फ्री हैंड जॉइन तो या द मरक द ब्रेक पॉइंट हम त लाइते तत्ते हैबा a दगी b द ये ओरे derivability द ग्राफ त रिफ्लेक्ट ओबो ngam de hair class द ngam खिनि कॉजिक मंकी नो स्टैंडर्ड से द याव देन खला दोना थर्ड कंडीशन फंक्शनल वैल्यू एट a गा फंक्शनल वैल्यू एट b गा माने हैबे मीनिंग दे मबानी के अनि से a गा a द लेबा b द लेबा मागे हाइट तो माने हैबने अदुइ तारी सी a द b बो कि मरक त लेबा मागे कंटीन्यूअस ओरबा कर्व टू द एट लीस्ट अ पॉइंट हम फंगने हैबा मसाई स्लोप 0 मींस टेंजेंट लाइन अमा ये उकांदा लाइन दो स्लोप 0 अमेना x एक्सिस का पैरेलल ओइन हाइ गेबदा टेंजेंट लाइन हम फंगे सी फिगर जिदा x एक्सिस द पैरेलल यारे को Similarly, another graph am the coin yang kan the function do kari mo oscillate or magadi tangent line ani phang si the namu Canada x-axis the parallel. So geometrical interpretation of Rolle's theorem in a kari high now. Geometrically, Rolle's theorem states that there exists at least a point x equal to c belongs to open interval AB at which the tangent is parallel to x-axis. Magi geometrical meanings. Here it comes. So Rolle's theorem magi statement jiga geometrical jiga noi khangjan gada bani ko. Mathang da mean value theorem say MBT harga yam samna khangnare or Lagrange's mean value theorem harga ju khangnai yam samna MBT harga dum khangnare se ko magi statement jina kamai tawi am tang yang si koina sai Rolle's khanggi do aduga samana doini only condition ani khaktang lakte ba. If a function f(x) defined on the closed interval AB be such that sai Rolle's ki minor first condition continues on closed interval, second condition derivable on open interval, the Rolle's ki third condition the log talk about f of A must be equal to f of B the yahondre condition ani sidang satisfied targadi MBT na haje there exists at least a point C belongs to AB such that f there C equal to f of B minus f of A by B minus A no so f there C slope so na kan f of B minus f of A by B minus A is jo mo graphical representation da kamai lai do khoi graph am tang amung yeng chiko sei graph da function da continuous hobe no khoi curve am ye sai A ge wang muduga B wang muduga sai Rolle's di manar mani handa unte MBT di manar dra ju yamni na manar dra ni du ge wang mudu ajari continuous hobe na A gi B da khoi freehand curve am lai re ada A gi ma pa da point lai riba A of fa hai ba B gi ma pa da mathak ta lai riba point B of f of B hai ba point ani jo join to kan koi we get a chord am phangi aduga marak ta lai ba tangent ma khoi na thiru ni chord to the parallel oiba ya ba tangent lai ba yam kan amal lai ma tangent ma sa C hai point to the sini sai slope ani manar ga di line ani parallel oi hai ba 11 da kon tor ko do sai MBT ki statement do the f there C equal to f of B minus f of A by B minus A do slope ka related slope ani manar ga di line ani parallel oi have do parallel thirak pane so MBT the geometrically mean value theorem states that there exists at least a point C belongs to AB at which the tangent is parallel to the chord joining the points A f of A and B f of B. That is the extremities of the function. Extreme point ani the joint of a chord to the parallel ba tangent am pangne have. So sini akoina chapter 5 ta yaw ba topics me am akoina theoretical akoi discuss to minari me am se do akoina sida koi hoji pokta discuss to kan da summary oina standard derivative me am do umtang remind to mina sikam sini akoina some standard derivative sida pulap akoina discuss to da yawgri me am to si formula me am se noina umtang mayek sengna bahar tok tho do makha ta ba topics me am da koi amu discuss to mina. Thank you.